Taal Volcano just produced its 11th eruption in 45 days. The footage is from a thermal camera. The eruption happened in the dark. At 12:16 AM, Philippine Standard Time, on Saturday, May 16th, 2026, the thermal cameras at Taal's main crater recorded a minor phreatic eruption. The plume rose 300 meters above the crater rim. The crater itself sits inside a small lake. That lake sits on a volcanic island 5 kilometers wide. The island sits inside a much larger lake, Lake Taal. Lake on island in lake. Taal sits in Batangas province, southwestern Luzon, 65 kilometers south of Manila, a metro area of more than 14 million people. The volcano is one of the most active and one of the most carefully watched. Since at least 1968, it has produced episodes of elevated seismicity, rising lake temperatures, and ground deformation. In January 2020, a major phreatomagmatic eruption sent a 14-kilometer ash column into the sky, displaced over 100,000 people, and killed at least 39. But here is the detail that tells the real story. International media will register the May 16th event as a minor phreatic eruption. That phrasing matches the bulletin. It leaves out what makes it significant. What is almost nowhere reported is that phreatic eruptions do not require fresh magma to reach the surface. They are driven entirely by water flashing to steam when it contacts hot rock or hot volcanic fluids. They can happen suddenly, without the usual magmatic precursor signals, even at the lowest level of unrest. They are also the type of eruption that killed 63 people at Mount Ontake in Japan on September 27th, 2014, at a volcano that was, until the blast, considered calm. The volcano did not need new magma to do this. The water under the rock was enough. The question is what it means when a volcano produces 11 eruptions in 45 days, while officially classified as low-level unrest. This is what the thermal cameras saw on Saturday morning. At 12:16 a.m., Taal Volcano Island sat in complete darkness. No human observer could have seen what happened. The only instruments watching were the thermal infrared cameras at the main crater and Daang Kastila Observation Stations. They recorded around the clock, calibrated to detect heat against cold rock and water. Both cameras captured the eruption simultaneously. A burst of hot steam emerged from the main crater. The thermal signature rose in a column of bright heat against black. Within seconds, it reached 300 meters above the rim. The Filipino term for this type of sudden steam burst is pusngat. PHIVOLCS, the Philippine Institute of Volcanology and Seismology, uses the word in its public bulletins. It describes what the cameras recorded, a brief, sharp pulse of vapor, vented and gone. PHIVOLCS did not specify the duration of the May 16th event. The previous phreatic eruption at Taal on May 8th lasted 6 minutes and also produced a 300-meter plume. After the burst, conditions returned to baseline. No volcanic smog, no upwelling of hot fluids. The alert level remained at 1, the lowest level of unrest on the Philippine volcanic scale. But the permanent danger zone designation did not change either. The Taal Volcano Island remained closed. These restrictions have been in place since the 1960s because Taal is the kind of volcano where steam bursts can happen at any time. This is what almost nobody outside volcanology actually understands about phreatic eruptions. A phreatic eruption is a steam explosion. No new magma needs to rise. No new pressure needs to build. The system only needs water, heat, and a confined space. The water comes from groundwater seeping through fractures, lake water percolating through porous rock, and pore water trapped in volcanic deposits. At Taal, all of these are abundant. The volcanic island is surrounded by lake water. The crater contains a hot lake, and the rock beneath is saturated. Water is literally everywhere around the vent. The heat comes from the magmatic system below. Even when no fresh magma is rising, the rock at depth remains hot, several hundred degrees Celsius, where groundwater circulates. Heat at depth is the trigger. When water contacts rock that hot, it does not boil gradually. It flashes. The phase change produces a roughly 1,700-fold volume expansion. 1 cubic meter of liquid water becomes 1,700 cubic meters of steam in a fraction of a second. Water flashes to steam, and steam expands by a factor of 1,700. The expansion has nowhere to go but up. The expanding steam blasts loose rock, ash, and vapor out of the vent in a sharp, violent burst. Blasts of steam and fragments can be sudden and energetic. Phreatic eruptions are not the same as phreatomagmatic eruptions. A phreatomagmatic eruption involves direct contact between water and actively rising magma. A purely phreatic eruption involves only water and hot rock. Both can happen at the same volcano in the same week. Phreatomagmatic events are a different process. The unpredictability is what makes phreatic eruptions dangerous. Because they do not require magma to rise, the typical precursor signals, earthquake swarms, ground deformation, and sulfur dioxide spikes, may be subdued or completely absent. The volcano can appear calm minutes before the blast. This is the volcano that watches itself from across a lake. The crater lake itself is small, hot, sulfurous, and slightly acidic. It has been elevated above ambient temperature for decades. It absorbs heat from below, releases steam and gas above, and acts as a pressure cap on the magmatic system. Monitoring is dense. PHIVOLCS operates multiple observation stations around the caldera. Seismometers record volcanic earthquakes and tremor. Gas spectrometers measure sulfur dioxide. GPS stations track ground deformation. Between May 6th and May 13th, the Seismic network recorded between 2 and 19 volcanic earthquakes per day, with 1 to 5 periods of volcanic tremor lasting up to 23 minutes. Daily gas and steam emissions rose as high as 600 meters above the crater rim. The permanent danger zone designation is permanent for a reason. It does not lift when the alert level falls. The kind of event that happened at 12:16 a.m. on May 16th can happen at any hour, on any day, regardless of what the instruments are saying. To understand why a 300-meter steam plume is worth reporting, look back 6 years. On January 12, 2020, Taal produced a major phreatomagmatic eruption. The eruption column reached 14 kilometers into the atmosphere, lava fountained from the main crater. Flights from Ninoy Aquino International Airport were grounded. The Philippine Department of Health reported at least 39 deaths in the weeks that followed. That was alert level 4 territory. That was a magmatic event. That is not what is happening now. The current activity is at alert level 1, low level unrest. Low level does not mean inactive. In April 2026, PHIVOLCS recorded 9 eruptive events at Taal, 4 phreatomagmatic, and 5 phreatic. In May, 2 more phreatic events were logged. The pattern is not a crisis. The pattern is also not nothing. The crater is doing what a phreatic-active volcano at low-level unrest does. It is venting steam periodically in short, sharp pulses. This is not 2020. It is not silent either. Just steady, low, and watched. It is still going. The thermal cameras are recording. The seismometers are counting earthquakes. The lake inside the crater, inside the volcano, inside the bigger lake, sits on the heat. The question is not whether Taal is still active. It is. 11 minor eruptions in 45 days. The question is not whether this is a major magmatic crisis. It is not. The alert level is 1. No homes have been threatened. The 2020 disaster is the historical anchor, not the current state. The question is what it means when one of the most carefully watched volcanoes in the world produces 11 steam-driven explosions in 45 days at low-level unrest. And the only reason we saw the most recent one is because the cameras were recording thermal infrared at 12:16 in the morning. A volcano can do this. A volcano does do this. At 12:16 in the morning on Saturday, May 16th, 2026, Taal Volcano vented a 300-meter plume of steam into the dark. The alert level did not change. The lake did not stir. The danger zone did not lift. The next pusngat has not been scheduled. The cameras are still pointed at the crater. If this story is worth telling, subscribe. We cover more of these every week.